Hey guys, welcome to our first video lesson. This is in Unit 1, which I'm titling The Basics, and it's Lesson 1.1, which is all on significant figures. So for today, our CLO is we're going to express solutions of problems with appropriate degrees of accuracy, and then orally explain our strategies using academic language when we come back and we're doing in person, or when we're doing small breakout rooms in class. So the first thing I want you guys to do is in your binder or in your notebook, the very first page you need to set up as your table of contents, like the one I have below. So you'll need 3 columns. The left-hand side will be your date. The middle will be the topic. You'll need the most room there. And then the far right will be the page numbers that you use. If you've used any kind of like interactive notebook before, this is very similar to that. In the first line of your table of contents, go ahead, write in Unit 1, the basics, right? We're going to organize this by unit and by lesson then. And then indent a little bit. You'll indent for each of your actual lesson numbers here. You can go 1.1 significant figures to write that in. As you finish setting up your table of contents, go ahead and note the agenda on the left-hand side. We're going to look at the chapter outline, and then we're going to take some notes on sig figs. So we'll look at the rules, have a quick check for understanding, then some rounding rules, another check for understanding, and then a word problem example. And then a final checkup for understanding, and then we'll wrap things up at the end. So again, this is a video. At any point in time, you can pause in case you need to catch back up, or if I'm going too quickly, all right? So our chapter outline, this first chapter is just 4 lessons long. So today we're looking at sig figs. Next class will be percentage error, and then 1.3 is laws of exponents, and 1.4 is scientific notation. It's kind of a hodgepodge of everything. I'm kind of designing it that way to let you guys go over some maybe hopefully prior knowledge things while we get used to kind of how life is working here. And these are super important things because they're going to come up on a ton of your exams and tests. They kind of just keep cycling throughout. So let's dig into our notes. I am big on organization, so I like to have my notes set up nice and neatly. So how I would like you guys to do it is on the top left-hand side of a blank page, you can go ahead and write the actual lesson number and title. I do recommend doing both. All right, so step 1 here, 1.1, significant figures. After you've got that, the next step is to go ahead and put today's date in the top right-hand corner. This date is probably not correct when you're watching this, so just put whatever date it is that you're watching this in there. And lastly, write the page number every time you start a new page. So this is our first day of notes. So this is page 1 of your notes. So put that down in either the bottom left or bottom right-hand corner. That's up to you. As we go through notes, you're going to keep labeling. So our next page will be page 2. The page after that will be page 3 and whatnot. I don't recommend right now going through and just writing out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, because there may be days when I give you a handout and ask you to input that into either your notebook or your binder, and that'll take up a page number. So just do it as you go. Don't do it all right now. All right, so our first actual notes for today, we're going to go ahead and start by defining what a significant figure or figures are. And as you can see here, it's laid out. So sig figs are the number of digits in a value, which is often a measurement, that contribute to the degree of accuracy to the value. That's kind of the annoying definition, to be honest. Like they come out from science, actually, where you are measuring things, and it is all about like how accurate you're being to something. Like, are you accurate to the nearest meter, to the nearest centimeter, to the nearest millimeter, to the nearest hundredth of a millimeter? Things like that is where sig figs come into play, because when you do calculations with them, calculations are really just estimates based off of how accurate your initial measurement was. But for IB, the important part here, right here, is IB typically expects answers to be rounded to 3 sig figs unless otherwise stated. All right, so we're going to have to beat into your brains that we're going to 3 sig figs pretty much every single time. And I'm going to explain how to do that in a second. So with sig figs, we've got a bunch of rules, all right, of what counts as significant and what doesn't count as significant. So rule number 1 here. So all digits 1 through 9 are always significant. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Anytime that shows up in a number, it's always significant. So for example, 129 has 3 figs. Got 1, 2, 3 values that are between 1 through 9. Another way of saying that is any non-zero value is always significant. Rule number 2, zeros between significant digits are always significant. So here we can see I always look for right away are non-zeros. So this 5 and 7, 5 and 7, those are both non-zero, so they're significant. And then if we have zeros that are between the significant figures, so this 0 here and this 0 here are both in between our 5 and our 7, so that means that they are always significant. So this number, 5007, has 4 significant figures. Rule number 3, trailing zeros in a number are significant only if the number contains a decimal point. All right. So in our example, 100.0, this does contain a decimal point. And these trailing zeros just mean zeros to the right. So like in this number, each of these zeros, 0, 0, 0 here, are trailing the 1. So we would call each of those zeros trailing. And since they are in a number that contains this decimal point, we have 4 sig figs. Each of those values counts as significant. If we compare that to a number like just 100, even though it looks like the same number, it's not quite, because we don't know exactly what degree of accuracy that's from. This would just have this single one as a sig fig. These trailing zeros here do not count as significant because there is no decimal point in that number. Rule number 4. Zeros in the beginning of a number whose only function is to place the decimal point are not significant. So it's really good practice normally in math, if you're using a decimal point, to write this 0.0025 to make sure you're really showing where that decimal point is. That's great practice. However, these leading zeros are not significant. So that's not significant, not significant, not significant. Only this 2 and 5 are significant. So this value would just have this number would just have 2 significant figures. And rule 5, zeros following a decimal sig fig are significant. So we just said leading ones don't count, but trailing ones do count after a decimal. So in this 0.000470, just like our previous one, these leading zeros are non-significant. 4 and 7 are, because they always are. And then this trailing 0 after the decimal is also significant. So it has 3 sig figs. This last example here then, our leading 0 to place the decimal is not significant, but this 4 and 7 are, and these zeros are also trailing. So that means they are significant. So we've got 5 sig figs there. And these are our 5 rules of sig figs that you're going to need to know pretty much for the next 2 years. You're going to use these in your science classes a lot also, just an FYI. And potentially engineering as well, although I'm not so sure on that one. I know this is a lot and it's kind of confusing. I promise with practice, it becomes significantly easier. It just takes some time to get used to the format is all it really is. So that's why we're doing this as the very first lesson so that you get 2 years of practice to really master this stuff. Let's go now to a couple more examples. where we are just determining the number of sig figs in these values. So if you want to take a second to just pause to kind of just like try these on your own right now, feel free. I'm still going to go over them, but it is good practice just to test your own knowledge right now. So let's look at this first value, 21.35. Well, if we're going to count the number of sig figs in this, remember that every single non-zero value is significant. So all four of those values are non-zero, so this has 4 sig figs. Let's go to our next one, 1.25. Again, any non-zero value is significant. That's non-zero, that's non-zero, that's non-zero. So there are 3 sig figs. On to the next, 305. Well, I always count our non-sig figs first, so that 3 and 5 are significant. And then remember, if you took down really good notes, rule number 2 said that zeros that are sandwiched or that are between 2 sig figs is also significant. So that 0 is between the 3 and the 5. That makes it significant. So this number has 3 sig figs. Fourth one here, 1009. Very similar to this last problem. Again, our non-zero values are significant, and any zeros that are sandwiched between those, like these, are significant. So this has 4 sig figs. Sorry, my computer's a little unhappy. That says sig figs there. Next up, 0.00300. Whoops. Again, I always recommend just starting with the non-zero values. We've got a 3 there. We know that's significant. Now we know from rule number 5 that our trailing zeros after a significant value, that's after a decimal point here, do count as significant. So these are significant. However, our leading zeros never count as significant. So nope, 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 not significant. This only has 3 sig figs. And lastly, 0.002. Well, our 2, that's significant. And then just like our previous example, these leading zeros do not count as significant. So this only actually has 1 sig fig. And that kind of demonstrates these rules for how to determine the number of significant figures in a number. So now what we're going to do is actually have a quick check for understanding. So on your screen, it should automatically stop and a question will pop up for you to answer. So go ahead and complete that now. Welcome back from your check for understanding. Hope you did well on it. The next section of our notes that you should label is we're now rounding to specified degrees of accuracy. All right, so sometimes it's just assumed, or if it doesn't say anything, you always round to 3 sig figs. However, sometimes it will tell you round to 1 decimal point, or round to 3 decimal points, or only round to 2 significant figures. So we need to kind of know what the problem's asking us to do because our final answer does mean quite a bit in terms of that. We can lose some really easy points there just from rounding errors. So some common notation that you'll see in this textbook especially is SF just stands for significant figures, like we've been talking about. And DP stands for decimal places. And again, just to reiterate, remember, unless otherwise stated, always go to 3 sig figs. And our standard rounding rules, remember, is if it's 5 and above, give it a shove, or you bump the previous place value up 1. 4 and below, you just keep it low and round it down to a 0. So let's just look at these through a couple examples. For part A, right, we've got the number 0.1235. I'm not sure where this mark is coming from. Let's get rid of it. Now, you can see they're wanting us to round to 2 significant figures. So what I always recommend that you do is identify the first number of sig figs or decimal points or whatever that they're asking for. So this is asking for 2 sig figs. So I'm going to start working left to right and identify my first 2 sig figs. So this leading 0, we know that is not significant. Then 1 is significant, 2 is significant. Now, those are 2 sig figs. So we're going to use the next number to the right as our rounding number. And this is where we're going to apply our rounding rules of 5 and above, give it a shove, 4 and below, keep it low. So this 3 is below 4, right? Or it's 4 and below. So we're going to keep things low. So this is telling us how to round this 2. It's saying to keep it low, so we're going to keep it as a 2. So this number just rounds to, whoa, that doesn't look right, does it? Apologies. Going to round to 0.12. And now that's correct to 2 sig figs. Notice that 3 and 5 just kind of drop off. We don't want to put zeros there because that makes them significant then, right? Our trailing zeros after a decimal are significant. So we're just going to leave them hang off. They're not there. Let's go to part B. 0.2965, we're going to 2 sig figs. Same practice again. We're going to count out our first 2 sig figs. So that's not significant, significant, significant. Now our third number is this 6. So we're going to use that to round our 9. And 6, right, that's above 5 for our rounding rules. So we're going to give that 9 a shove up to the next value. So that 9 rounds up to a 10. And if you remember then, that 10, we kind of got to carry to keep bumping up this next value then as well. So this is actually going to round to 0.30. Again, that 9 is becoming this 10. That's why you see that 0. And then when that 9 becomes a 10, that means we're going to bump the 2 up to a 3 as well. And then this number is correct to 2 sig figs there. Part C, we're going 415 and a quarter to 3 sig figs. So again, identify your first 3. 1, 2, 3. Our 2 becomes our rounding number. That 2, it's below 4, so we're going to keep that 5 low. We're just going to keep it the same. So this number just becomes 415 to 3 sig figs. And lastly, part D. So we've got 3,050 correct to 2 sig figs. So we're going to have to identify our first 2 significant figures. Our 3 is significant. Now this 0 is significant because it's sandwiched between the 3 and the 5. So that makes it significant. So that makes our 5, this third value, our rounding number. 5 and above, give it a shove. So we're going to shove that 0 up to a 1. So now don't just write 31 because 31 is not anywhere close to 3,050. This is going to become 3,100. We're replacing that 5 and 0 with 2 other zeros, right? Because we're just rounding it to 3,100 there. 31 is nowhere close to 3,050, so that's not where we're going to go. If it's trailing zeros before a decimal, remember that those are not significant. So this is still correct to 2 sig figs. All right, let's try another check for understanding. So that should pop up again. Go ahead and answer that. Welcome back. Last bit of our notes now is actually where we're going to come back to the CLO and wrap things up. Because remember, we want to express solutions of problems with appropriate degrees of accuracy. Up to this point, we've just been kind of learning the rules of rounding and of sig figs. Now we're actually going to solve problems and apply those sig figs. So let's do it. Example 3. Oh, an important note. Holy smokes, I almost forgot this. Never round until your final answer. A common mistake that I always see is students will round like steps of a problem to sig figs. They never want to do that. Always wait until the very end. Use all unrounded values until the very final calculation. Okay? So for this example 3, we've got a circle that has radius of 12.4 centimeters. Well, shoot, anytime I see that, guess what? I'm drawing a circle. That was a really small circle. Let's draw a bigger circle. Ooh, I've got a circle tool too. Let's play with that. Circle. Look at that. That is freaking fancy. So, circle. And it's got a radius of 12.4 centimeters. Remember, a radius is from the center of that circle to its edge in a straight line. So we can label that as 12.4. And we want to calculate part A, the circumference of the circle, and part B, the area of the circle. And we want our answers correct to 1 decimal point. So let's do that. Part A. First up, circumference of a circle. We need to know the formula for that. Well, to remind you, the circumference is equal to the pi, or to the pi, 2 pi times the diameter of the circle. Now remember, diameter is just the whole way across here, so that dotted line continued over here. So that's just going to be double of whatever our radius is. So for this problem, well, I guess we can write this out. Another way to write that is to replace that diameter with 2 times the radius. So we can just write 2 pi r to represent 2 times that radius, and then still times pi. So using that, now we'll have the circumference is equal to 2 times pi times the radius, which is 12.4. And now what I mean here by don't ever round until your final answer is that if you use 3.14 as an approximation of pi, like most people know to do, it could potentially give you a wrong answer to the degree of accuracy that they're stating. We always want to use those unrounded values. So we need to actually use the pi button on our calculator. And I've got this, come on, there we go. I've got this calculator set up. This should be the same one that's on your Chromebooks that you can use. Just go to the search and type in TI or calculator, and it should come up. And we're going to actually use that pi button. So pi is right above the division symbol in blue, that up caret button. So to get to that, I don't know how well you can see my calculator because I'm not using a mouse here. But we'll just go 2 times, and then we have to hit the second button to get to that pi value. So second up caret gives us that pi. And then we're multiplying that by our by our radius, which is 12.4. And now we're getting a final answer that's unrounded. But we're going to take this value now and round it to 3 sig figs. Now, what IB wants or typically likes to see, and what I like to see also, is to go ahead and write out the full solution with an equal sign first. So 77, sorry, this calculator bogs down my computer a little bit, 911,49781. By showing all of these values, you're basically like showing whoever's grading your test that, yeah, you know what's going on. So like you get the correct method points here, but now to round to 1 decimal point for the final answer, we're just going to do that basic rounding. So 1 decimal point means we want to round to this first decimal right after the decimal point, right? Or the first place value after the decimal. So since that's where we want to end up, this 1 is going to be our rounding number, and 4 and below keep it low. So we're just going to keep it the same. So our final answer is, ooh, and you know what? I used an equal sign there. Whenever you're rounding, you should never use an equal sign. It's an easy mistake. You should use this approximation symbol like that, the little curvy equal sign. That's approximately. So our final answer here is 77.9. Sorry, that is a 77.9. Let me clean that up so when I save this, that looks a little prettier. 7. Oh, it's going to do it again. Whatever. You guys get it. 77.9. So that's part A to 1 decimal point. Part B now, we want the area of a circle. So our formula for the area of a circle is pi r squared. So we're just going to throw our values into that. So now we've got pi times our radius, which is 12.4. And we're going to square that. So now we'll just go back to our calculator and do basically the same thing, just with these new values. So we've got pi times 12.4 squared, and that gives us a really, really close exact value of 483.0512. Oh man, come on, Chromebook. 12864. Okay, let's get rid of this app since that's completely slowing my computer down. Maybe. There it goes. All right, let's get rid of you. Now I'll be a little happier. All right. So we've got that pretty much exact answer. Now we just need to round this to 1 decimal point. So we get our area being approximately equal to, and again, 1 decimal point. So this is where we're trying to round to. This is our rounding number. Remember, that's a 5. 5 and above, give it a shove. So we're going to shove that 0 up 1 value to a 1. So our final answer is 483.1. And you know what? I forgot my units were in centimeters. So this area, remember, is centimeters squared, and circumference is just a length. So that is just centimeters. And that is how we would solve these problems and round to the appropriate degree of accuracy. So a final check for understanding for this video. Go ahead and answer that question. Welcome back from that check for understanding. Hope you did well. Let's just wrap up this lesson now with what we have covered. So we started looking at the 5 rules of sig figs, and we looked at, hey, the first rule is all digits 1 through 9 or anything that's non-zero are always significant. Zeros that are between significant digits are always significant. Those sandwiched zeros are significant. Rule 3 is that trailing zeros in a number are significant only if the number contains a decimal point. Rule 4, zeros in the beginning of a number whose only function is to place the decimal point are never significant. And 5, zeros following a decimal significant figure are always significant. Remember, unless otherwise stated, always round your final answer to 3 sig figs. And only round your final answer. Never round numbers until the very end, right? So those intermediate steps, you never want to use an approximation there for anything. All right, that concludes lesson 1.1. We'll come back to class next time in person. I'll answer any questions that you have, and we'll do a bunch of practice problems so you get really confident in rounding things to 3 sig figs. Thanks, and I will see you in class.